Welcome everybody. This session is for the introduction of a new design method for Geogrid stabilized foundation rafts with multi-axial Geogrid. And we're gonna hear from Aaron Schlesinger and also from Garrett. And Aaron is a graduate of New Mexico State. He joined Tensar International in May 2011 as a regional manager for the southwestern US prior to joining Tensar. Mr. Schlesinger worked as a product manager and project consultant for Contact Construction, designing roads, bridges, and drainage structure for numerous transportation and infrastructure projects throughout Arizona. He also gained extensive experience in civil roadway design and construction as both civil project engineer and land development project manager for Centex Homes. Mr. Schlesinger now manages the sales, marketing, and R&D efforts for Tensar International Roadway, foundation and grade separation products and design services in Arizona, Nevada, and New Mexico. Aaron is married with 2 boys, lives in Chandler, Arizona, and in his spare time, he spends his time with his family and friends, playing golf and officiating college basketball in the winter. Garrett is based in San Diego, California. Mr. Fountain is a civil engineering graduate from the University of Arizona with emphasis in geotechnical engineering. He has over 20 years of geotechnical engineering and construction experience. As a principal engineer of one of Southern California's leading geotechnical engineering firms, Garrett was involved in numerous public, private, and design build projects. Technically, Garrett is experienced with various geotechnical design softwares, FE modeling techniques, and pavement design methods, including AASHTO 93, AASHTO WARE-ME, FAAR Field, and PCASE. As Tensar's West Area Engineer, Garrett provides engineering support for a variety of Tensar technologies that include flexible and rigid pavements, crane pads, load transfer platforms, and liquefaction settlement mitigation under foundation. In addition to spearheading Tensar field validation program, Garrett is a liaison on numerous Tensar research and testing initiatives and has authored several published research documents. And with that, I'm going to turn it over to Aaron Schlesinger.
Great, thanks, Alf. Appreciate the introduction there. I'll just give a quick background on Tensar and this particular project, and then get out of the way, let Garrett dig into the details and talk about the design methodology. For those who don't know Tensar is headquartered in Atlanta, Georgia. We are the inventor of Geogrids and provide full-time service solutions for customers around the world. Our products are backed by extensive research, and our highly qualified team of engineers, scientists deliver design and construction support unequaled in our industry. We help engineers, contractors, and owners use Geogrid to achieve more cost-effective, reliable solutions for pavement construction, soil stabilization, and earth reinforcement. As far as this project goes, we were approached by Nino and Moore several years ago to just really do some brainstorming and come up with some solutions that would be specific to the needs of this particular project. We kind of went out to our utilized some of our national research and testing, along with local research and testing with local soil conditions, implemented federal guidelines from AASHTO and FHWA, and really developed a design methodology to help quantify some of the the numbers, put together the math and the numbers behind some of this design methodology that has been developed and widely utilized now. So Garrett was kind of the quarterback on much of that research, as well as pulling it all together and implementing the design. And so I'll hand it to him and let him take it from there.
Thanks, Aaron. Thanks, Alf. Yeah, so this was a great project because we're able to work with the Arizona DOT, Nuno and Mora office there locally. Let's see, is this not? There we go. Hit the button harder. All right, so State Route 347. This was a railroad crossing that was going over what? I forget. Do you remember the road that was going over, Aaron?
Yeah, it was over 347.
Okay, yeah, there we go. State Route 347 and a railroad crossing. So you can kind of see a cross section here on the right. You had an MSE wall with a bridge going over 347 with the railroad on top, and then we constructed a Triax Geogrid raft on the bottom. So what were the challenges, facing this project? Soil challenges, right? We had soil collapse, potentially expansive soil. We had an MSE wall that was going above it, and you had the potential for differential settlement. So, that was one challenge. Another challenge, as geotechnical engineers, many times we use geogrids and we don't have good ways to quantify the benefit of geogrids, especially Triax Geogrid. So that was another challenge. This was a DOT project, and they were going to have to specify Triax Geogrid. Can ADOT specify Triax, which is a proprietary product, in a project? And then will the contractor be able to install the Geogrid, the Triax Geogrid? So there's just a few challenges that this project had. So challenge one, soil collapse. Really, we're trying to, mitigate the potential for differential settlement. What are we going to do? We're going to use a Triax Geogrid stabilized raft. And the way the raft works is you put in layers of Geogrid and with good granular fill around it. And when you apply that load, it's going to move that load and get more surcharge transfer out with Geogrids in your stabilized granular material than you would without Geogrid. Other benefits, basically you increase the bearing capacity, distributes the stresses to the underlying soil, so they're not going to experience as much distress or as much stress. And then because they're not experiencing as much stress, it's going to reduce the potential for differential movement, especially when you have a very uniform surface above those layers. So that was the solution. That's how we addressed challenge one. Challenge two, how do you quantify the benefit of Triax Geogrids? There's a number of methods and ways people evaluate geosynthetics. Many times they start to look at tensile capacity and other methods, but Tensar, we always kind of take a unique way of looking at things, and we actually developed a new bearing capacity design method. It's called the T-value method, and it measures how efficiently the granular material with Geogrid in it transfers and distributes loads. And this is a great method. It's actually been out now. This project was in 2017. This method started to debut like 2015, 2016. We have laboratory testing for verification. We have a validated numerical model, so we can model it in Plaxis and FLAC and other finite element programs. We have many documented case studies. State Route 347 here is just one of them. And it's been published in many different technical journals at this point. So how do we model Geogrid? Historically, people will look at Geogrid and they'll look at trying to look for a tensile strength. But when you do that, you're completely ignoring, I call it the interaction the soil has with the Geogrid, right? So you put a Geogrid here, you're going to have completely stabilized soil properties right here next to the Geogrid, and then you kind of move out to non-stabilized soil properties. Usually this distance depending on the material, ranges between 12 to 18 inches. So in our case, when we actually have layered systems, and if I had another geogrid up here, you're really getting a fully stabilized soil column. And that's key to the performance here. So when you're going to evaluate geogrids, you really need to test the soil and the geogrid together. And that's what we did. This is our large scale triaxial device. This is a 1/2 meter in diameter and 1 meter tall. And we put a geogrid in the middle with strain gauges coming off of it. So what are the benefits we see out of that, right? You get additional shear strength. That's where the increase in the bearing capacity comes in. Significant additional shear strength once you add geogrid to your materials. And then greater ductility, right? Whether you're looking at structures or even pavements, a more ductile system, through many cycles is going to perform better. As opposed to without geogrid, you kind of see, the shear strength is going to start to dwindle, or even if you're looking at pavements, you're going to have resilient modulus degradation occurring. So based on our large-scale triaxial testing, our many different numerical analyses that we did, we came up with a new design method for bearing capacity. So QU is is the load that's being applied, QU. QS is what are the bearing capacity of the existing subgrade, that material down there is. And then H, which is basically the thickness of the granular material, over B, which is the width of the load that's being applied. And then you have this parameter here, this T. T is the load transfer efficiency of that granular material. So all granular materials have efficiency of transferring loads, right? That's why we do over excavation and compaction during geotechnical engineering, right? And here we kind of developed a relationship when we look at the undrained shear strength of the subgrade material, normalized by the effective overburden pressure. So we find that ratio, and you can go up to, this is our line here for the Triax stabilized gravel raft, and you can come over to what T is. So then you have T, and at this point you have a very simple equation to put in for strip footings and square footings to evaluate bearing capacity for Triax stabilized gravel rafts. So this is a very simple equation. You put it into an Excel sheet, but we actually have software that I hope will probably be debuting Q1 or Q2 of next year, where you can put in your project parameters and you'll get an answer out for you. So our next challenge is, this was the DOT project, right? So with the DOT, very sensitive to specifications, very sensitive to proprietary products. And, we've designed it using this GeoGrid, these specific parameters and all the testing that we've done. How do we know that, when it goes to design and goes to construction, that's going to be met, right? As from a designing standpoint. Well, the answer is yes. So ADOT was able to specify the Triax GeoGrid. There was a project special provision that was created to do this. We did kind of do a little bit of spec defense during the project, but ultimately we were prevail, and the GeoGrid that was specified for the project and used in the design was used on the project was great. Bonus question, this is kind of new. Can proprietary products be specified on FHWA projects? The answer is, well, commanding yes. October, look at that, almost a year to the date, October 28th, 2019, FHWA came down with a ruling where you can see here, this final rule rescinds the requirements limiting the use of federal funds in paying for patented or proprietary materials or specifications or processes specified in project plan specifications, thus encouraging innovation in transportation and technology. So by the FHA removing, the previous restriction, it opens it up to any kind of proprietary products. Arizona DOT still has their own stipulations that need to be met, but this is kind of one hurdle here. If you have an FHWA project, that you can use proprietary products. Challenge 4, will the contractor be able to install Triax Geogrids? The answer is yes. I mean, Geogrids and the Triax Geogrids have been used on hundreds, thousands of lane miles at this point. Many contractors are familiar with it. They know how to place aggregate base on or any kind of granite material with it. And it can be placed very efficiently. I mean, we regularly do highway projects with Geogrid. You can use rubber tired equipment, roll over it. You can use belly dumps. You can place the Geogrid. So yeah, most contractors can work with the Geogrid. Additionally, call on your local Tensar representative. Aaron here locally has a lot of experience working with Geogrid in the field and can help contractors place the Geogrid efficiently and help the resident engineers or engineering support on site to make sure that the product's going down properly. So what were the challenges? Well, what challenges, right? So we mitigated the potential for soil collapse and potential expansive, right? So take care of the differential settlement. We're able to quantify the benefits of the Triax stabilized foundation used with the t-value method. I can tell you I had a very similar project in Colorado with the Colorado DOT, and one of the biggest benefits was that the DOT, they liked the concept, they wanted to use it, but they needed something to stand behind. And they said, well, can you quantify it? And it says, yeah, we can quantify it, and it's something very simple to understand. Can ADOT specify tracks? Yes, you can. And the contractor was able to install it. So overall, this is a very successful project. So at that point, that's kind of the end of our presentation there. Kind of keep it short and sweet going into our Friday afternoon. So if anyone has questions, we can answer them now.
Yeah, there's it doesn't appear to be any questions there, Garrett, but I'll chime in and ask you, was this the first time that the design methods that you used on this one, was that the Virgin project in Arizona, or have this been done before in other parts of the country?
This method has been done many times before in other parts of the country and internationally, this method. And then the Triax Geogrids have been used quite a bit in Arizona. So. Right.
No, I do recognize that. I was just referring to specifically the design methods associated with it.
Yeah, this design method, I believe it was the first one using in Arizona and with the DOT like this.
And yeah, I don't see any other questions here. So I guess that concludes the session. If there are no other questions to be asked.
All right.
Give it a few more seconds here to see if there's anything being typed in.
I think they said there was 52 viewers taking in the presentation. So I don't know if they have the option to ask questions by audio or not, or it's just via chat.
I believe it's through chat only,
okay.
Aaron.
Yeah, I think so. That may be the case. So. All right. Well, please, I would just say, Alf, if you don't mind, stop by the Tensar booth. We've got a lot of information regarding these foundation designs. Contractors, we get a lot of questions about how to cut through geogrids and what that looks like and what the issues are with cutting through geogrids. We've also got information regarding our asphalt interlayers. As well as our walls and slope systems that are ADOT approved systems and have been around for a number of years. So happy to answer any questions here, or we'll be in the chat room all afternoon. So
There is a question that came in here, Aaron, from Rachel. And she says, how does the triaxial geogrid compare to the biaxial? And she's talking about cost and strength.
Okay. Yeah, great question. We get that all the time. So the biaxial grid has been around since the early 80s and still works very well. There's a type 1 biaxial geogrid, and the DOT is just upgrading their specification. I've been going through that for the last several years. There's now it's now a type 2 specification. So all that means is it's a heavier geogrid that is able to create a stiffer section and with less aggregate. And so we are now a type 2 geogrid state, which is a good thing because we're taking advantage of the economics of the material. So the Triax geogrids there are a series, there's about 7 different series of Triax geogrids. They all basically start at the type 2 level of performance and go up from there. So really depending on what you're trying to accomplish, we've got larger, stiffer, very, very stiff geogrids that are used for mining haul roads, pit run material, larger 4 or 5 inch minus aggregate. We're able to lock that up with the larger, stiffer products. And so those you're going to be looking at, $4 or $5 range per square yard. And then it kind of goes down from there. A lot of the roadway geogrids that are used for pavement enhancement are somewhere around $2-3 a square yard, and right in line with where the biaxial geogrids are as well. So we've got more options now with the different Triax grids as well as the biaxial grids. So we're happy to give you options on those designs as you look at them individually, based on what your project needs are.
And I just want to kind of add to that. So the Triax Geogrid has been out on the market now for 10 years. And most of our research, and the research that we use to validate this design is all based on the Triax Geogrid. So from a designer's perspective, I can validate the numbers in the design for the Triax Geogrid. We haven't done any, research or testing on biaxial geogrid now for 10 years. So it's kind of an outdated product.
All right, I appreciate that, both Garrett and Aaron, a great presentation. And thanks to Rachel for asking questions. And with that, I think we are done with this session, and we'll turn it over to the next session.
Thanks so much.
All right. Thank you.
Bye.